Okay, hopefully now you've had a few moments to factor these polynomials, so let's check the answers and see how well you did. Alright, so 12, 13, and 14 are pretty simple. 12 is big X, so you're finding factors of 24 that add to be negative 10. It's negative 6 and negative 4. 13, again, is big X. You're looking for factors of negative 90 that add up to be a positive 1. That's positive 10 and negative 9. 14 is a perfect square, so that's difference of squares because of the minus sign. So that's x plus 5, x minus 5. Next, we have 15 to 17. 15, you have a common factor of 8x that needs to be factored out first. So that is 8x times x squared minus 8. 8 in this case is not perfect, so we cannot factor this anymore with the x squared minus 8. So 8x times x squared minus 8 is your final answer. 16 is 3 terms, but we have a 2 there. It's not a GCF, so we need to slide and divide. So we slide it to the back to make it x squared minus 7x plus 12. We're looking for factors of 12 that give us negative 7. That is negative 3 and negative 4. We divide by the 2 that we originally slid to the back, and then play bottoms up, which is 2x minus 3, and then the 4 over 2 reduces to 2, giving us the x minus 2. So 16 factors into 2x minus 3, x minus 2. 17, big X again, gives us x plus 8, x plus 1. On 18, we are given a common factor of 4, so that needs to factor out first. That gives us 4 times x squared minus 16. In this case, unlike number 15, 16 is perfect. So I can factor again the x squared minus 16. So this completely factored is 4 times x plus 4 times x minus 4. Number 19, we have 4 terms. So what we're going to do is look at the first 2 first, do the GCF, look at the second 2, find its GCF, and hopefully we come up with something in common in the parentheses. 4x to the third minus 5x squared have a common factor of x squared. When I pull it out, I have 4x minus 5. 28x minus 35 have a common factor of 7. When it is factored out, you have 4x minus 5. Now I have 2 terms with the same factor of 4x minus 5. So I can pull it out, and what I'm left with is the x squared plus 7. So, in 19, my final answer, completely factored, is the 4x minus 5 times x squared plus 7. Lastly, we have 2 more examples of grouping. In the first one and in the second one, if you notice, there's a minus sign between the second and the third term. Here, you're going to factor out that minus sign with your GCF so that it creates the same sign in the parentheses. 20 and 21 work just like 19. In 20 you get 3x minus 1 and 5x squared minus 8. In the 5x squared minus 8, neither one of those are perfect squares, so it's not difference of squares and we are allowed to stop. In 21 we have 6x minus 1 and x squared minus 3. Again, 3 is not perfect, so we cannot continue this problem any farther. The last 2 problems on your page are special polynomials, meaning they're not m squared or x squared in this case. They are to a higher power. What you're going to do is use quadratic techniques to solve them. There are 3 terms, so you still solve them the same way you would a 3-term polynomial. In 22, that would be big X. So you're looking for factors of 4 that give you 5. That would be 4 and 1. And then that would factor into m squared plus 4, m squared plus 1, which then reduces to what you see. In 23, that is a perfect trinomial, if you remember that from completing the square. If not, we'll talk about that on a different day. If you do, then you can follow the pattern. And if not, we can use slide and divide here to give us 2x to the 4th minus 3 times 2x to the 4th minus 3. At this time, if you have any questions on any of these factoring problems, pause the video now and ask Miss Lewis. Otherwise, we're going to talk about how to solve quadratics by factoring. Remember, there are quadratic equation has a degree of 2, meaning it's the highest exponent. To find the value of the variable in the equation, we just simply set it equal to 0 and factor to solve. Do you remember what a quadratic graph looks like or what the solutions represent? Hopefully, you know a quadratic graph is a parabola and the solutions are the x-intercepts. Again, we are going to talk about this more in detail on Monday when we review everything for quadratics. But for now, we're going to talk about how to solve by factoring. It's really nice and easy. The first thing we do is solve for x when the expression is already factored. If it's already in parentheses, completely factored, all you have to do is set each parentheses equal to 0. So in 24, x is 9, x is negative 8. If there are any questions on that, ask Miss Lewis. Otherwise, pause the video now and do 25 and 26. 25, you get 1/3 and negative 1/4. 26, you get 2/3 and positive 7. Again, if there are any questions, please ask Miss Lewis. Step 2, well, what if the problem's not factored? We need to factor it and then we solve it. So it's putting together the previous problems of 12 through 23 with what we just did with 24 through 26. So we're going to factor these and then you're going to set each piece equal to 0. So in 27 and 28, they are both big X problems. So you factor them using the big X method. 27 would be x plus 10, x plus 3, while 28 would be x plus 8, x minus 4. And then you set each piece equal to 0, giving you negative 10 and negative 3 for 27, and negative 8 and positive 4 for 28. If you have any questions, pause the video and ask Miss Lewis now. Otherwise, complete number 29 and 30 on your own. Pause the video before checking your answers. Alright, 29, you slide and divide. Then your answers are negative 3 and negative 2. 30 is a GCF problem, and you get 0 and 7/2. If there are any questions on these two problems, please pause the video now and ask Miss Lewis. Otherwise, let's look at some word problems. 31 and 32 are more than likely how your state exam is going to ask you these questions because it's an application type problem. In 31, you're building a square patio. The area of the patio is 16m squared minus 72m plus 81. What are the dimensions of the patio? So it's asking you what the length and width is if you're given the area. Again, you should be able to recognize that 16m squared minus 72m plus 81 is a perfect trinomial. If not, you can solve this by slide and divide. Either way, 4m minus 9 squared is what it factors into. So your dimensions are 4m minus 9 by 4m minus 9. In 33, it tells you have a rectangular prism, so that's a 3D shape, with volume of 4x to the third plus 30x squared plus 36. What linear expressions can be represented to be the possible dimensions of the problem? So remember, volume is length times width times height, and a linear expression means there's no exponents like y equals mx plus b. So what we're going to do is just factor this. First off, they have a common factor of 2, so when I take out the 2 and the x that they have in common, I'm left with 2x squared plus 15x plus 18. Then we're going to factor this piece here, bringing our 2x down each time. To factor the 2x plus 2x squared plus 15x plus 18, we use slide and divide. So we slide the 2 to the back, and that would be x squared plus 15x plus 36. Factors of 36 that give me 15 are 12 and 3. Divide out the number we slid originally, gives us 2x from our GCF, x plus 6 from 12 divided by 2, and then 2x plus 3 playing bottoms up. So our linear expressions are 2x, x plus 6, and 2x plus 3. If you have any questions on 31 and 32, now is the time to ask Miss Lewis. Please pause the video and ask. If there are no questions, then you need to complete the review for exam review day 1.